So in this video, we're going to review the idea of domain. Remember, domain are your set of x values that you are allowed to use in a function or an equation. So normally in a function, for example, like a polynomial function, x cubed minus 3x plus 2, you're allowed to substitute in any value of x that you want. You know, you can plug in 0, you can plug in 3.1, you can plug in pi. You can plug in anything you want. You're going to get a y value out. So if you're allowed to plug in absolutely anything, positive numbers, negative fractions, whatever, then your domain is going to be all real numbers. And the way that we denote that is from negative infinity to positive infinity. All right. So there are really two exceptions to this rule. One exception is if you have a denominator. So if the function, and we'll just call it numerator over denominator. If it has a denominator, the denominator cannot ever be 0. It can be anything else, but it can't be 0. So for example, if I have a function g of x equals x plus 2 over x squared minus 5x minus 6. All right, I want to avoid numbers that are going to make this denominator 0. So I don't want it to be 0. That's why I said it not equal to 0. The numerator can be anything you want. There's no issue with the numerator. It's the denominator that can't be 0. So I set my denominator not equal to 0. This is a quadratic. So the only way you're solving a quadratic is either by factoring it or using the quadratic formula. And since we really haven't talked about the quadratic formula much, all of these should have been able to be factored that you saw on your quiz. All right, so x minus 6 times x plus 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 gives me negative 5. Set each factor not equal to 0 and then solve for x. You can't just say your answer is negative 6 and positive 1 because you didn't solve for x. So x add 6, subtract 1. These are the two numbers that you have to avoid. Otherwise, you can pick any number you want on the entire number line. So to say not equals on a number line, we put an open dot. But it can be all the other numbers. One of the things that I noticed on quizzes was some of you were just randomly writing down intervals, but didn't show it on a number line, and I think the number line would help you out a lot. You go from negative infinity to negative 1, parenthesis, because it's an open dot, pick up the middle interval, negative 1 to 6, and then pick up the last interval, 6 out to infinity. And that would be your domain for this one. I'll give you another function here. G of x equals x plus 2 over just x minus 5. Well, again, this has a denominator. We set it not equal to 0. This one doesn't need to be factored, though. This is just get x on one side, numbers on the other. It's not degree 2. So the only number we have to worry about is the number 5. If I plugged 5 back into this function, 5 plus 2 is 7, 5 minus 5 is 0. 7 divided by 0 is undefined. But I can pick any other number on the number line. So again, draw that up. Not 5, but all other numbers. Notice in the previous example we had 3 scribble spots here. We had this one, that one, and then the third one. And I had 3 different intervals. This one I have 2 different shaded in spaces. So for this answer, my domain is going to be from negative infinity to the number 5, parenthesis, 5 to infinity. Again, open dot means you can't use the number 5, so no brackets here. Okay, so denominators can't be 0. Didn't worry about the numerator at all, just denominator can't be 0. The other issue that we have, and you can look back through your notes, is if I have a square root. So if my function has a square root in it, let's just call it square root of n for whatever, then I set the radicand greater than or equal to 0. Whatever's under here has to be a positive number or 0. And the way that we say positive number or 0 is by saying greater than or equal to 0. All right. So, for example, if my h of x is equal to the square root of 2x minus 3, I set the radicand greater than or equal to 0. Whatever that is, it's going to have to be a positive number, or it could be 0, because you can take the square root of 0. Square root of 0 is 0. That's why we've got the equals here. Solve for x. Add 3, divide by 2. All right, and I get x is bigger than or equal to 3/2. Graph this. Some of you got this part on your test or quiz, but you wrote up the wrong interval for it. Filled in dot at 3/2. Greater than or equal to means you're heading off in the positive direction. So I'm going in this direction. From left to right, I start at 3/2 and go out to infinity. This is my domain for this function, which means if I pick any number bigger than 1.5 and plug it back in, I'm taking the square root of a positive number, and that's good. I can't take the square root of a negative number. Right? The only caveat to this is if the radical is in the denominator. So if I have h of x equals, I don't care, anything in the numerator divided by the square root, and now the square root's in the denominator. Now, again, because of the radical, it's going to be greater than, but not the equal symbol, because you're in the denominator. So anytime you see a radical, you better start writing the greater than symbol down. If it's up in a numerator, it's greater than or equal to. If it's down in a denominator, it's just greater than 0. So an example of this would be x plus 2 over the square root of x minus 5. The numerator doesn't have a radical in it, so I don't worry about the numerator at all. It's the denominator that gives you issue. You set the radicand greater than 0, solve for x. X has to be a number bigger than 5. So when you give me an interval notation, and I'm going to graph it first, I'm going out to positive infinity with an open dot on the 5. This is going to go from 5 out to infinity. No bracket. See the difference? The h of x over here was up in a numerator. There was no denominator. That radical was in a numerator, so it's greater than or equal to. This radical is in the denominator, so it's strictly greater than. So the last possible case you could see would be like this. P of x equals the square root of x plus 5 over x minus 3. Okay. So I have a radical in the numerator, which means I set the radicand greater than or equal to 0. And again, the only reason I'm messing with the numerator of this fraction is because it has a square root in it. The denominator, all right, is automatically set not equal to 0. There's no radical here, so I'm not using the greater than or equal to symbol. This is straight up not equal 0. Solve for x. So x has to be a number bigger than or equal to negative 5. X can't be 3. All right, so bigger than or equal to negative 5, solid dot. X can't be the number 3, keeps on going. All right, so can you again see that we've got two branches here from negative 5 to 3, open dot, parenthesis, and then on the other side, 3 to infinity. Okay. If you didn't do the WebAssign 1.4 questions at the end, there are like 4 questions at the very end of 1.4 that I mentioned prior to the quiz, you might want to try those now. There's also going to be, and I'll send this out in an email, additional practice questions. So I'll give you the other version of the quiz that you can practice on as well. And then you can either give them to me to check or, bring them in on that Thursday when I'm in the Math Learning Center, and I can check them then.